Today we are going to talk about how to find all the solutions and their imaginaries. First, we got to just realize, how many solutions does this equation have? Well, it's a power of 3, therefore it has 3 solutions. This one has a power of 4, therefore there's 4 solutions. Or 4 zeros in this case. Now, I need to find all the zeros of this. Well, first I've got to find P and Q. Alright, so my P in this case would be plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. And then my Q is plus or minus 1. So P over Q is plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. These are all my possibles then. Now I have to synthetic division out to find all of my zeros. And I have to get it down to an x squared, or down to 4 terms that I can factor by grouping. Alright, so I start syntheticing this out. 1, negative 4, 4, 10, negative 13, negative 14. Okay, we'll do 1 first. Drop the first one. 1 times 1 is 1. 1 times negative 1 plus negative 4 is negative 3. Negative 3. 1, 1, 11, 11, negative 2, negative 2, that one doesn't work. Okay? Now we'll try 1, try negative 1, drop the 1, negative 5, 5, 9, negative 9, 1, negative 1, negative 14, 14, 0. That one works. Okay? So right now we know one of my solutions is x equals negative 1. Okay? And from there we can use this then to see if there's any more solutions. We can just go from right there. Plug in 2. Drop the 1. And we'll do this in another color actually. Plug in 2, drop the 1, 2, negative 3, negative 6, 3, 6, 7, 14. That one works then. So we got another one. 2. Okay? And then we plug in the other ones. So we can use this from here. Because if I do this one by grouping, right now I have an x cubed minus 3x squared plus 3x plus 7. And if I group this one and try to factor it, x squared, x minus 3, this one would just be 1 plus 1, and it would be 3x plus 7. And those don't match, therefore we can't factor that by grouping. Okay, so we got to keep going on. And I go to start putting ones in, and I put in negative 2. It doesn't work. That doesn't work. Okay, and I go through and I put in then 7. That doesn't work. It's way too big. Negative 7 also doesn't work. And if I went through all the way through all these, they wouldn't work. Now when you do that, you go, okay, well I can't do any. So I got to go back and plug in solutions that I already have. So I'll plug in 2. And I drop that down. And at 2, negative 1, negative 2, 1, to 9. That doesn't work. So we're close though, okay? Because that means there's only one other option. Plug in negative 1. Drop the 1, negative 4, 4, 7, and negative 7. And that's 0. So now what we have, okay, is f of x equals, this one would be x plus 1. And then we have two of those, so x plus 1. And then we have x minus 2. And I'm going to have to rewrite that because I'm not going to be able to fit it on the screen. So let me rewrite that. F of x, x plus 1, x plus 1, x minus 2. And then we have our last factor here, which is x squared minus 4x plus 7, which we got from right here. Okay, and so now we can factor that. Well, we will find out that there's no factors of 7 that sum to negative 4. The only factors of 7 are 7 and 1, and I can't get that to add up to negative 4. So we have to use our quadratic equation. So that would be x equals negative b, or 4, plus or minus the square root of 4 squared minus 4 times 1 times 7, all over 2 times 1, which reduces to 4 plus or minus the square root of negative 12 over 2. Negative 12 reduces to plus or minus 2I square root 3 over 2, and 2 comes out all those, and my answer is 2 plus or minus I square root 3. And so my last solution is 2 plus or minus I square root 3. And those are my 4 zeros. My 5 zeros, okay? Because remember, we had a double negative 1 right here. Double negative 1. So we have 5 zeros. So there you go. All right. Find all the zeros of this one first. Okay. Find our p. Plus or minus 1, plus or minus 3, plus or minus 9. Q, plus or minus 1. P over Q is going to be plus or minus 1, plus or minus 3, plus or minus 9. So we go to do our synthetic division here, and we end up, we'll do 1, 7, 15, 9. Go 1, drop the 1, 1, 1, 8, 8, 23. That one doesn't work. Do negative 1, drop the 1, negative 1, 6, negative 6, 9, negative 9. That one works. And so x equals negative 1. And let's go to rewrite this because we've got it already down to squared, which is our goal. So we got x plus 1, x squared plus 6x plus 9. And so f of x equals x plus 1, and then we can factor that. Factors of 9 that sum to 6 is 3 and 3. 3 plus 3 equals 6, and so it's x plus 3, x plus 3. So all our answers are, let's move this. All our answers are then x equals negative 1 from right there, and then x equals negative 3, and we don't need to write that twice because negative 3 is negative 3, so we only need to write it once. All right. Write a polynomial function of f of at least the degree that has the rational coefficients of this. Well, first, these are our answers. If we were to rewrite them in form, it would be x plus 1, x minus 2, x minus 4. And then I would FOIL it because it wants us to rewrite the polynomial. X squared minus 2x plus x minus 2 times x minus 4. Reduce that. X squared minus x minus 2. And then FOIL it again. X cubed minus x squared minus 2x minus 4x squared plus 4x plus 8. And then add up our like terms and we're done. X cubed minus 5x squared plus 2x plus 8. But sometimes you're going to have irrational ones, like this one. 4 plus square root of 5. Well, if there's a plus a rational of that, then there is the irrational of it. There's the other irrational of that, of 1 minus square root of 5. So you're going to have to, if you get an irrational, you're going to have to find the other irrational. Okay, which just means it's the conjugate of that. Okay, so then we need to set this up. So f of x equals x minus 4, x minus 1 plus square root of 5, x minus 1 minus square root of 5, and then we can distribute the negatives here. That should be a 1 there. Distribute our negatives here, so f of x equals x minus 4, x minus 1 minus square root of 5, x minus 1 plus square root of 5. And then we multiply through, but multiply the irrationals first. X minus 4, and then you're going to get x squared minus x plus x square root of 5 minus x plus 1 plus square root of 5 minus square root of 5. And then minus x square root of 5 plus square root of 5 plus minus 5, because square root of 5 times square root of 5 is 5. And then all your square roots cancel. So this cancels, and you end up with f of x equals x minus 4, x squared minus 2x minus 4. And then you need to distribute again. So x cubed minus 2x squared minus 4x minus 4x squared plus 8x plus 16. Add up my like terms, and that is my polynomial. X cubed minus 6x squared plus 4x plus 16. And that is the polynomial. All right. Let's do another one with an imaginary. If there is a imaginary, then it's got to have its conjugate. So 3 plus I. All right. So now we rewrite that. We get f of x equals x minus 3, x minus 3 minus I, x minus 3 plus I. And I rewrite that as f of x equals x minus 3, x squared, no, sorry, got to distribute the negative, minus 3 plus I, x minus 3 minus I. And then I distribute f of x equals x minus 3, x squared minus 3x minus ix minus 3x plus 9 minus plus ix, and then the last one here, it's actually going to be minus 3I, and then we multiply through the I there and we get plus ix minus 3I minus I squared. All our i's will cancel, so ix's cancel, the 3 i's cancel, this negative I squared cancels to plus 1. And now we need to add up all our like terms, so f of x equals x minus 3, x squared minus 6x plus 10. Distribute again, so f of x equals x cubed minus 6x squared plus 10x minus 3x squared plus 18x minus 30. Add up my like terms. End up with x cubed minus 9x squared plus 28x minus 30. And there's the original polynomial with the degree of 1.